Well, welcome and thank you for coming. My name is Giori. When I submitted the talk, I was at ZEDEDA. I'm actually left ZEDEDA last month, so I'm no longer at ZEDEDA, but I'm still a big fan and participant and advocate for the LF Eve open source project that I'll be showing off and talking about. And I had intended to do more hands-on edge orchestration, but just over a week ago, fell on my mountain bike, broke my elbow, had surgery a week ago. And so underneath this jacket is a bandage and a lot of stitches, and you just don't want to look at my arm. That meant not much typing except for single-fingered over the last week. So I've toned down some of the hands-on stuff. I am going to do a live demo of one of the cool sort of debug access to remote application tools toward the end. But really, I would just want to explain to you, you're all aware of challenges at the edge and deployments, and so I want to show off some real deployments of where the Linux Foundation Eve project is being used by big industry, and open source really is a value for those cases. So I'll first start off with just some pictures and describing a bunch of use cases where Eve is actually running on the edge, being used. I'll get into the technology implementation, but what Eve is just a bare metal secure operating system, and all the applications and stuff that are running on top of it are deployed by the users. So the users of Eve are deploying software applications, are deploying all sorts of different application technology at the edge, and Eve is just that bare metal secure resource. Much like when you deploy applications to the cloud, you don't know what the bare metal OS of that server in the cloud is. You just want to deploy your applications up there. So Eve is meant to be that framework for the edge. So I'll explain a little bit about technology implementation, and then I'll finish it off with a hopefully kind of cool demo of what's a recent feature addition in the realm of the Eve world. So starting off with some use cases, if you went over to the expo hall, you'll see there's 4 kiosks, and one of the kiosks says oil and gas, but it really includes some other energy sectors. And one of the use cases, they send these robots down into wells of oil wells, and they have to test the cement. They have to test there's a whole bunch of certification and regulations you have to do to pass that it's not going to break and have huge damage of man-made disasters of oil spills. And so they send these robots down, and Eve is used to allow them to run the data in real time at the edge, process it, and then send the metadata to the cloud, because in these locations, you don't have a high-speed network connection to the cloud. Sometimes it goes away, sometimes it comes back. There's a lot of cellular involved in this, but it's a very, you'll see in these use cases that Eve is often deployed in difficult-to-reach places. So another case of wind turbines. How often do you want to send someone up to visit a wind turbine? Not often. So you instrument the thing, and you analyze the vibrations of the windmills, and you try to do the repairs as needed. And so Eve is running there with some vibration analysis so that they can understand the maintenance schedules better. And one of the benefits of Eve is it's redundant OS, so you're not going to brick the device even when you do updates over the air. Scale is another big advantage of Eve. Is like you can replicate this, just like the Dent project that was talked about an hour ago. You really want to scale this with minimal complexity. So you can create a project that says, I want you to do this, this, and this, and these solar farms, they're all the same. So you just have some cloud config-like parameters that might be different per device, but then it's just like you get a brand new node comes up, gets assigned to the project. It may automatically be set up with network policies, applications to download, all these different things. They can be provisioned before they're shipped or after they're shipped, and you don't need IT experts after the fact. And so in this case, this customer in a white paper says how they were able to reduce the complexity and the time of the provisioning quite significantly. Another interesting use case, I think, is for all these companies that have complex equipment products that they sell that get shipped to their customers. Well, how do you do that Xbox or entertainment TV systems, constant periodic updates of your software, of the applications? I used to work in the Wi-Fi router space, and once upon a time they shipped the Wi-Fi routers with some firmware, and it lasted the life of the router, right? You never updated things. Now at the edge, you're doing AI, you're improving your ML models. You've got to be improving that software over time, doing CI/CD pipelines. So this is a case of a manufacturer that takes advantage of Eve as a lock on the bare metal, and then they're able to upgrade their applications. It could be upsells of software applications, upsells of services, in fact, that could be done here. And then there's another interesting case of just making our buildings smarter, conserving energy, conserving resources. What does that mean? We have to instrument the world, to instrument these buildings, and then somehow we have to take advantage of learning from that instrumented data and then applying key results to improve how they're monitored. Like lights go on, lights go off, automatically save energy. And so there's some interesting smart automation use cases. And then this picture was just like in September with VMware Explorer was an announcement of a partnership where VMware is actually on the lower end of the physical spectrum of devices where their stacks, virtualization stacks, can't go that low. Then they'll use Project Eve. And Eve will run then at the edge on the lower threshold virtualization devices. And you see a background, the monitor there is showing the ZEDEDA controller. And then I did, I think it was August, I did a whole talk on this biodigester plant in Chile, a remote location in Chile. It was a really cool project of multiple LF Edge projects. We had Project Alvarium for the data integrity. They worked with the IOTA Foundation for the data transfer across the blockchain. And then Eve is running on this Dell server. You see in the bottom over here. This Dell server was set up by Trevor of Dell, and he shipped it. He installed Eve, shipped it out there, and then the IOTA Tangle software and the sensors for the flow meters and all these things were aggregated and put together in a way that nobody had to go to Chile at all. They just had somebody plug in the network, and then they now have been streaming data, and it's a greenhouse gas emissions credits that the country of Chile is actually getting based on the results of these data and these biodigester plants. I don't know if you know what these are. I consider them like, imagine a cow eating and drinking and pooping and peeing, and all this methane gas comes out. Biodigesters take in all sorts of inputs like grape harvest, industrial bio waste, and liquid or solid, and then they produce the fertilizer in liquid form or the compost form, and all the methane gas is used to power this facility and then some. So they power their own facility. So it's a really cool project. So in a nutshell, with these use cases, you can see that industry adoption is real. The Eve project has, I think, really solid adoption in production in the real world. Thanks to ZEDEDA for getting those customers that are going to run it. And then, as I mentioned at the intro, although Eve secures the bare metal, it does nothing, really. It's not a traditional Linux OS. It does nothing without being told by a controller, what should I run? What configuration changes should I make? What applications get access to what hardware resources, what interfaces, and so forth. So the cloud, or it doesn't have to be in the cloud, but the controller is really key, because Eve, when it first boots up, it talks to its controller, and thereafter, the only thing it listens to is the controller. And this sort of sets it up as well, where you don't have to have any expertise in the field, because all of the IT and OT administration can be done via the controller. So the node, when it first boots up, it phones home, it sets up a TLS link through the network, through the internet, and the certificates are, registered on both ends. That way you don't have any usernames and passwords at the device. If you physically stole that device, you couldn't do anything with it because it only listens to its controller. There's no local login or admin capability to do anything with it. Most devices have hardware root of trust, and so that's used to store all the keys and secrets. So you'd really have to reverse engineer and take apart the device to be able to do anything with it. And then again, because of the phone home aspect, the distributed firewall, doesn't matter if there's proxies in the way or any sort of convoluted networking. You imagine these equipment manufacturers that sell into other customers where the networks are all different, all crazy. You don't want, the IT people shouldn't have to do anything except make sure at least there's one route out to the controller, out to the internet. And this little layered security model, well, Eric Nordmark, the CTO of ZEDEDA, has got a whole talk on that one tomorrow. So if you want to get into the weeds of the network security model, there's a lot going on there. I mean, the project was designed with security in mind from the ground up. And then lastly, the API for Eve is completely open, so there's an open source implementation of the controller, but it only works through the command line. And then the commercial implementation, the only one I'm aware of is ZEDEDA, but if you needed to do a direct API implementation, you'd have to be the controller, or there's an API that's published, that ZEDEDA publishes, so you can actually have many interactions over APIs to the controller, and the controller is the only thing that Eve listens to. And that sort of helps with your user policies and process models, because the controller is still that one lock and key by some IT person who has full control over the bare metal of the box. And just to show, this is a little deeper dive, it just shows that Eve can penetrate through proxies and not lose or open any messages. It is end-to-end signature verified. I didn't have a lot of detail on Eve. Is about 250 megabytes, and then there's a full redundancy, so you have to have at least 500. You should have at least a gig of storage so that you can store a backup and the current Eve image, and then an additional storage for whatever applications you want to run. So Eve is probably a pretty thin layer of a low-level bare metal Linux distro, and then all the applications that you run on top of it are virtualized. And Eve ZEDEDA controller sets up all of these firewall rules between the virtualization layer, so as a user you don't have to figure all that out. You just have to know how it works. And there's oodles and oodles of options and flexibility there. It's all based on open source. It's not like Eve was started from scratch. There's all sorts of great projects that have been integrated to make that work. And even more recently, we start seeing all of these networking at the edge applications. And pretty much now, if you have some number of NICs or for whatever you need, you can turn any edge application server into a network, high performance network appliance if you want to, if you know how to deploy the software. So this is just another image that I pulled off the LF Edge website. Eve, again, was one of the founding projects of LF Edge, and there's if you want to get involved, there's a calendar for the biweekly meetings every 2 weeks. The wiki has information. There's a mailing list. Most of the communications just of help and new users and stuff goes via Slack, because the community definitely hangs out on Slack. GitHub, there's more than just the Eve repository, because there's also testing and open source controller, but Eve is the main one, and that will link you to everything else. And then the Docker Hub allows you to build Eve installer images. So Eve, one of the other intents is it's supposed to run on any hardware. So you just create an installer image by running this Docker script, and we'll do it for you. You don't have to go to the source and build the distribution from scratch. You just run this Docker command, and you can give it a specific Eve image, or you can just, image version, or you can just say, give me the latest and greatest. And when I was at ZEDEDA, I was running the developer program, and thankfully, it's still running and exists. It's close to being pretty self-service without much back-end manual processing of new users coming into the program. It's free. The demo I'm showing is running on this developer program cluster. So there's a free trial to check it out, and it's not that difficult to go. So before I go into the demo, I'm just going to give you a couple of screenshots to give you a sense of what I'm going to show. One thing is that while I was there, just to make a very simple application that people could deploy, this is a container application, but it could be a full-blown virtual machine. There's a little container we call Hello Eve. It's on Docker. And I've already have a node live and active connected to a ZEDEDA controller of the developer program, and that node is running this application Hello Eve. And then I'm going to, in real time here, enable Edge View, and it allows me to remotely sort of tunnel into the application. The application is just a simple web server, Nginx web server, but I'm going to be able to tunnel in because I don't have remote access to that web service on that server from here. Through the internet, I wouldn't otherwise be able to see it. And the cool Edge View command, the coolest Edge View command that I'm going to use is the TCP command. And it's the thing that sets up the tunnel between the local container's IP address and port and maps it to local host and another port on my laptop. And you can actually have multiple TCP tunnels going on at the same time. So this is a very powerful, very cool command. And you can run all sorts of other commands too to check out Eve and other applications. So, and the way it works is, so when I log into my ZEDEDA controller, I'm going to see that the IP address of Hello Eve is going to be a certain IP address, and I'm going to just TCP map that IP address of port 80. That's all I have to do, and it will tell me the result of where it's mapped to localhost on my laptop as a result of that command. And the way it works is actually through an independent dispatcher. So my laptop and Eve device are WebSocket linked, tunneled through a dispatcher. And that dispatcher has all the security of the controller behind it. And I was going to do the generate single-use image installer with bringing real hardware and plugging in USB and connecting it out, and that's just not going to happen. So that's not going to happen. But another cool product feature that I had done before I left was that you'll be able to generate an installer with secrets that the controller creates, so that when you install Eve, and it's a single-use time, all of the keys and secrets on Eve will already be known to the controller, so you just plug it in, let it boot up, and it phones home, and it registers automatically. Whereas in the current model before that, you had to run the installer, and Eve would generate its own keys, and then you had to take those keys and out of band go over and tell the controller about those keys. Now, if you let the controller do it, it's like, boom, done. So that's pretty cool. All right. Let's do some demoing here. Let's see, so here's let me just go home here. So this is you can see that this edge node is not here in Seattle. I just have one connected to this ZEDEDA enterprise. And there's all sorts of stuff I can just flip through. There's this edge node, the edge application instance it's running as this Hello Eve app. You can set up Kubernetes clusters if you have multiple edge nodes if you want. The libraries where you set up your data stores, your app images, you can see your Eve images that you've deployed. Reports are all sorts of things. One of the cooler ones is the network report. I'm not going to show you all this stuff. There's complete auditing of everything that's going on. Like, you can't get away with doing anything on this box without it being known or logged. And then lastly, the marketplace is the equivalent of, like, where's your easy button for applications? Like, when you pull up your smartphone and you click an app, you want it to just run. So somebody has to get the app to the state where it will just run. And once you do that, then all of these, like the Fledge project, Edge Foundry, all these applications, the Alvarium, once you get that easy button running by the core developers of that project, then me as a user, I can just deploy any of them by clicking buttons and going through a few panes, and boom, they'll work. So here was our Hello Eve app. It was one of these that was deployed. We're going to, and now I'm going to turn on Edge View in real time. So there's a bunch of charts. We know all the metrics and logs going on this device. We know what firmware version before 9.0, it was running 8.6. It's running this Hello Eve application, and I'm going to activate the Edge View session. And while that takes a little bit of time, about 20 seconds, 30 seconds or something, then what I mentioned before is over here on the app itself, basic info, I can look up and I can see that the reported IP address of this container that's running is 10.1.0.128. I'm going to need to know that when I set up my, so let's go back here. So now my session is active. It shows there was some default settings in the project of how long the session should be. This one looks like it's 5 hours is the default, so I turned it on at 4:40. It's going to be active till 9:40. You could set this up for days. It doesn't have to be hours. And then it's going to keep track of the commands that are run and log them and everything. But there's this cute little download script button. And I'm going to download my script. And that's where the magic starts to happen. So I had this directory here. If I say ls, now I have this new script, the run KG Super. And so now the first thing I have to do is chmod plus x, whoops, plus x. Okay, so now it's ready to be an executable. And the first thing I can do is just say -h, help, like what can you do? And so here's all these different commands. There's a whole bunch of different commands, and among these there should be TCP is in here somewhere. And so I'm going to run this command with TCP of my 10.1.0.128, I think that was it, on port 80. And that's going to set up my TCP connection, mapping it. That doesn't look right. Oops, I can't type. TCP 10.1.0.28. Okay, that will hopefully, yeah. So you see the response here that locally it says that it's mapping that port on the Eve device to my localhost port 9001. So if I just grab that or say localhost, now I've got this server long way away, and I just logged in and saw its local application web page. And it's linked over to remotely to a wiki, and you'll see on the Eve, on the open source wiki, there's a whole bunch of information about Edge View, about the architecture, about the, let's just open this up here, about all the commands. So if you want to know more detail about the commands than the man page, that's where you can see the TCP command and all these other commands that you can run. And then there's a graphical workflow that sort of shows how it gets set up and run. So back here, Edge View is running. There's all sorts of things I can run. Just a very simple app command will tell me what apps are running on this device. Hello Eve. And then if I look over here, let's refresh this page. It should show me, the last command I ran, the number of app instance commands I ran, and there will be a place over in the administration of the project that also has a summary. Actually, I can just go back here. Is summary right here of the Edge View sessions that are active and what's configured on the device for the different projects. So fortunately, that worked very well, the Edge View command and seeing the app. And And like I say, although it's very, hands-on, this is a, IT and application administrators' dream tool, because when you've got your servers in Chile and you've got them in some wind turbine, you really want to figure out what's going on. You can get into the nitty-gritty if you need to. I mean, ideally, these things should just be operationally running, and the whole goal of our technology is to make them ease of use where people don't have to get hands-on. But when you do, it's a very powerful tool. Like this TCP command, you can set up an SSH tunnel if you want to SSH into your application, if it's a virtual machine, if it's whatever it is. So you have all the power you need to be as if you're on the box itself. And then, let's see. So that's the gist of the demo that I wanted to show off. And so I'm gonna, like I said, I'm gonna cut it off shorter because I didn't really want to do a full-blown installation of Eve OS with my lame arm. I don't know if you didn't get here at the beginning, I had surgery on my elbow a week ago. So anyway, I'm gonna stop right there, and I have CTO Eric Nordmark and CEO Saeed Wisal in the room. So there's ZEDEDA questions that they'll be able to answer, LF Edge questions and Eve questions I can help answer. And so that's a wrap. Let me know if you have questions now. Right there.
Okay, so you had your applications there you had in the ZEDEDA store, or I'm sorry, whatever your term was for it. If I download one of those applications that needs access to, say, some of the lower level communications to actual talk to sensors, GPIO, Modbus.
Right.
Do I work through like your scripting like you did to set that up, or do I set up Eve to do that?
Yeah, that's a great question. So what happens let me go back to the edge node. So the edge node, if you look at the adapters, this shows that I'm using one of two of the Ethernet interfaces, but all of these other, so there's hardware models that describe every single I/O type of port on this device. And I can configure them, so if I went in and edit this, something like that, I can configure them to be a management port, like out-of-band management, but usually they're either app direct or app shared. So I can set up, the audio could be app shared, this COM port is app direct, and then there's tags you can apply, and so every single application has essentially a network and I/O policy applied to that application. And so then if I look at the application for, let's try to think, let's say Mosquito, it might say, so there's a mapping of just one of the ports through it, but different edge apps may require different interfaces to be available. So this has a bunch of port maps available. But then once you're running the application, yeah, you can apply all of the I/O policies on a per edge node basis. And then the same thing with network policies. There's the bare metal network interfaces, and then there's the policies that each application is allowed to have, whether they're, you can provide a NIC directly to an application and it gets maybe passed through or something, or it gets applied through a firewall of some sort. So it does have full-blown flexibility for an IT person to set the policies of the physical device, how that's applied through the virtualization to the application layer. And then there's a whole bunch of user, rules and administration. So if you look over in the administration side of things, there are different types of users. I'm going to show this because there's people's names and stuff like that. But there's roles. Yeah, this is a good page to show. There's roles that are predefined here, and then you could add your own role if you want and decide what types of permissions this type of user can do. So you have really fine-grained user permissions. If they're an operations technologist person, they get to use their app. They don't get to do something with the node. If they're just an IT, maybe they get to node, but they don't get to touch the apps. And then there's a layer above this where you can actually have multiple enterprise. You can, if you're one of the OEM customers, you maybe have a whole bunch of enterprises and what applications get provided to your customers. So one example of that would be like this announcement with Rockwell. Maybe they have their own applications that get deployed to the edge, and they get to decide what applications are pushed to all of their customers. So you get to decide essentially what's in the marketplace. Like this marketplace, this is just for demo purposes, but the owner of the enterprise gets to decide what applications are there, what versions of those applications are there, when to deploy them, and you can deploy them then at scale massively, or you can have some test devices, you deploy one or two. Same thing with the Eve images. You can test, you have your test nodes, and then you can deploy thousands at the same time. So it really is, the goal is to be like the cloud native applications. You, as an app provider, you don't have to worry about securing the bare metal. And then you have the value of scale, much like the consumer product industry, where you have to update thousands and thousands of devices. You don't have to do them all at once, but you have to have a way to scale it. Other questions? Has anybody tried Eve yet in this room, other than our ZEDEDA file? Okay, if you go to the web page, I'm telling you, you just click that little developer trial and you get free hands-on use. You just install your own device. I also used to do demos with Equinix Metal. You can deploy through iPixie. I can deploy Eve to an Equinix Metal box that I don't even have my hands on. You can deploy Eve to the bare metal and connect it up to the controller. It's kind of another fun demo. One more question? Say again? Like requirements for the kernel or the hardware?
Yeah, the two things, because there is a lot of restrictions at the edge.
Yeah, so you mean what sort of hardware resources are required to run Eve?
Yeah, it's just...
I can give you some sense by saying that, like with a Raspberry Pi, a 1 or 2 gig RAM wasn't enough. You needed like a 4 or 8, and you can run Eve on a Raspberry Pi. The industrial Intel boxes, x86 boxes out there, you'd be hard pressed to find one that couldn't run Eve. Most of those boxes have plenty of power.
But you don't regret the same flow, even with Raspberry Pi? If you were able to do it?
Sorry, with a what approach?
In terms of availability, right?
Availability. Yeah, so it will depend on what applications you run. Eve itself could run maybe on a 1 or 2 gigs memory, but then you would have no room for applications. So you need a 4 or 8 gigs of memory if you want to run some set of applications.
That's probably the one thing. I think it should be shown. It's really dimensioning of the hardware yet, because there is a lot of restrictions.
Yeah, but you would size, again, you would size the edge hardware based on your use case. And the beauty of like the partnership with VMware was they couldn't get to as small a hardware as Eve can get to. So you can do this edge orchestration scaling on pretty small devices. And with enough work, you could slim it down even further, but then you run into the problem of you don't want to have multiple Eve distro. You multiply your effort if you had a small Eve and a big Eve, right? So there's...
Maybe I can add to that.
Yeah.
But sort of, in many cases, the sort of use cases are that people have some initial applications they want to deploy, right? So they know what hardware resources are needed for that application, like this memory, whatever. But since they typically want the flexibility to update those applications in the future, or down the road, 3 years down the road, deploy some additional applications on the same hardware to do some deeper analytics, whatever, right? they typically want to have hardware with a bit of headroom to do this stuff. But sure, that might mean that from a hardware, from a cost perspective, you might end up paying a bit more upfront to get that flexibility. But in many cases, that's worthwhile because these remote locations, the truck roll to go and install a new version of the hardware, right? Even if you didn't use EVE, right? You build this targeted appliance today, and then 2 years down the road, you need a bigger app, and you need new hardware. That truck roll costs more than the hardware. Because you're going to send someone out on a plane ride, on a driving for a couple of hours to get to a remote location to install one device, right? It's really that distributed edge, the notion of having enough hardware headroom for, plan a couple of years, 4 or 5 years out into the future, makes a lot of sense to people.
Yeah. All these root here is really good, right? Is it application based, software based, or is that based?
So what's there today is there's the ability to run with RAID on the storage side. So if you don't think that your typically these things run with SSDs or unique drives, but if you don't think that those are robust enough, you can actually set that stuff up with mirroring or RAID or whatever.
Okay.
Just if you want redundant nodes today, that's up to the application, but it's something there's interest in the community to see what does it mean to add some sort of compute clustering capabilities as an option.
There's a great resource for answering your own questions. If you go to the EVE repo and click on the docs repository, they've really done an outstanding, I think, job of, storage, look up storage, or just do a search, and then you get a certain amount of, this one wasn't the best answer, but something like, deployment and how that works. It's written up in pretty well detail. The security story is written up in detail. This has the Equinix medal if you want to do a demo detail, deploying EVE for testing and demo. So the EVE docs repository has a lot of answers for you.
In terms of roadmap, there's also on the wiki, there's also things that
Right.
what the community is currently working on.
There's the EVE wiki, EVE in the market.
Under LFS.
Thank you. And, yeah, another question? Sorry.
Yeah, so we've actually got an edge solution already, but we actually meant to be more of a hypervisor that we could orchestrate workload on.
Mm-hmm.
And we started this software 4 years ago. We looked at something like VMware, and of course they wanted to buy bigger servers. They wanted to buy 3. They wanted to do vSAN. Pretty soon, you've got
Your hardware cost is
yeah,
high.
right. And we couldn't handle the burden.
Yeah.
And so we were looking at smaller things. We ended up with just a couple of open stack servers at the edge.
Mm-hmm.
And we didn't implement vSAN, we don't do Emotion or anything else. It seems like that's kind of where EVE is as well, right?
Yeah.
If you want redundancy, you just put them out there and you run 2 copies of the app, and you figure out how to fail over the application layer.
Yeah, if you're at the application layer, right.
Yes, that is what I said.
But customers are using Kubernetes as well, so that gives you all the failover and everything else. So you can deploy K3s.
Okay, so you could actually, you could have 3 nodes out there, and you could just run.
And then you have customers that actually do VM failover, so if the node fails, there's a VM. They don't state, there's no state replication, but the VM, because usually these apps are stateless, so then an app boots up on the second node. We have a customer that puts 2 of these line boxes in trucks, and they need to be able to complete the jobs that these oil and gas trucks do without having them go back to the depot to replace it. Okay. So we've done that deployment.
And again, you're doing it at the workload layer.
Yeah. So in the future, we want to do more storage and compute. And obviously, this is not a data center, and we don't store data on these boxes. It's all transient data to the cloud, but it's definitely an area for us to build on top of that. But the key thing is not bloat, and that's the key thing. We're trying to make sure it keeps running on Raspberry Pis or smaller, and there's actually a lot of improvement that we in the community have ideas around that we have not done yet about how to make it smaller and run a little more constrained.
But do you use Qbadge?
So there's ideas around how to leverage some of the KubeVirt and other things that are going on in Nexus. Yeah. So definitely invite you guys to be part of the community and provide thoughts and views. And now with Emerson coming in and others, there's going to be more and more computers pouring in as well. So it'll be great.
Yeah, part of it is sort of like, you have the industrial companies that they have applications they need to run at the edge, right? So they use factories or wind turbines or whatever, and then sort of marrying that with sort of IT knowledge that, and networking knowledge that sort of for the community. That's one of the key things that's very.
We're trying to find good solutions, but yet the point is really the dimension.
Yeah, it's not easy.
And the part is like reach a point that in some of our solutions we customize it by using communication. We put it on our own.
Yeah, so, as you hopefully will see, there's, we thought about it as well, like just run bare metal Kubernetes call it a day, right? That was an idea in the beginning of the company. Yeah, but then I think what I can tell you about this was not developed in isolation of customers. This was really done with some of the largest, enterprises in the world that have really tough environments to deploy in. And if it was that easy, then he would be better to do it.
We did the same, to be honest. We did there was a service provider where we traveled because your construction itself is a challenge for us. That's the issue.
Yeah, and particularly when you look at this sort of more industrial deployment, right? Or some people call it forex, but in fact, both you might have, you always tend to have some NAT firewalls and NAT. So you can't actually dial out these devices that need to dial home, right? And the typical data center solutions are assuming that everything can actually be reached, so that you can actually dial out and reach things. Furthermore, you might assume that everything is actually connected, and as things as you scale up, you're always going to have some things in your deployment that are not currently reachable because, some of these machines, right, they might be sitting in a factory, and when they go home at 5 p.m., they power off the whole machine, including the computer, right? So you want to update that one? Well, don't assume that you can update all of them at the same time, because it depends what kind of.
And all that 5G solutions.
Sure.
Basically, what
If that's available, that's one
No,
way.
it is.
But that doesn't ensure that the thing is actually reachable, right? So they might power up.
Yeah, but you see, when we speak about far edge, then somehow, for instance, we kind of discounted the far edge by saying private 5G. And in the end, what you do is really take the far edge, but you have all the boxes there. And in the end, it's the full stack.
We're creating definitely a new stack. But if you give an example of Kubernetes, there is no idea Kubernetes in the cloud. When you're running 2,000 trucks, 2 servers per truck, you're running 2,000 little Kubernetes clusters. That's a completely different problem than the cloud guys ever thought of, right? It's not like 2,000 single clusters with 2,000 workers. There's a few thousand workers, but they're all very segmented, right? So these are some of these challenges that how do you figure out the satellite, use case your customer
But you need to
satellite.
remember, you said 3,000, that's small compared to, for instance, what we do.
No, I'm just giving you an example. I'm not saying.
So,
Yeah.
if you exponentially, that is the reason why the net fuel initiative,
Yeah.
someone tries to work that one.
And so I think the idea is, as part of LFM and LFS, is to really collaborate, take the best experiences and build solutions for it. But yeah, it's an exciting time.
So I'll just wrap up. You can gather for more questions. I'll just wrap up. There are good resources that are open, publicly available on help.zededa.com, on the LF-Edge and LF-Edge wikis for the Project Eve, GitHub, lf-edge/Eve, and there's other repositories. So there's a lot of information online, and feel free to contact me if you have any other questions. So thank you very much.
Thank you.